In this video, we're going to be taking a look at the second functionality of the transform program, and that's the ability to find transformations between two given functions. So at first, this second functionality might be a little bit tricky to use, but it's not too bad if you get a bit of practice using it. So, what can this second functionality be used for? Let's say we have some question that gives us two functions, so these are both square root functions, and it asks us to find the transformations from one function to the other. And we can use the second functionality of the transform program to kind of automate this for us a little bit. So at first I want to go over how this program works. How we use it is we put in some kinds of base function. So in this case it would be just the square root of x. So the base function is the function with no transformations applied. If we know how to get from the base function to the first function, f1, and if we know how to get from the base function to f2, if we know these two transformations right here, all we need to do is put them into the cas, and the cas will tell us the transformations to get from f1 to f2. So if we can describe these two transformations and put them into the cas, which isn't really that difficult to do, the cas can automatically find this third transformation for us, which takes us from f1 to f2. So let's actually try this out with this question. So we want to put in the base function into the program. So let's load up the transform program, going to the catalog menu, going down to transform in methods functions. We want to put in the base function first, and in this case it's the square root of x. And then of course we have to specify the variable, which is x. And then we don't want to transform this program, so we'll put in a 0. But instead we want to find a transformation, so we'll put in a 1 right there. And it's going to pop up with this little text box saying this program will find transformations between two functions of the form a times f of n times x minus h plus k. And this is really important. You want both of these functions to be in the form a times f of n times x minus h plus k. You might have seen this form before, because you can actually pick apart each of these parameters and deduce the transformations from there. So this form is really important, and we want to convert both of these functions or these expressions into this form. So let's click OK, and the next prompt will tell us to ensure function 1 is in this form. So function 1 is this right here, and we want to put it into this form. So we already have the constant out the front, which is nice, so that's 3. Then we have our function, the square root function, and now we have to mess around with the inside a little bit, because it's not quite in this form of n times x minus h. So at first what I want to do is factor out the 2, so that's going to be 2, and then x plus a half. And then of course we have a plus 4 on the other end. So this is f1 of x still. So I hope you can agree with me that what we have right here is the exact same thing as what we have at the top here. And now we need x minus h. So in order to get negative in here, we can just do a double negative trick. So this is 3 square root of 2. Then we have x minus a half. And then plus 4. So this expression is the exact same thing as what we have right here. And now we can identify our a, n, h, and k values, because our a is 3, so a is equal to 3. Our n is just the constant in front of this factor, so our n is equal to 2. Our h, well, we have x minus something, so our h is that something itself, so minus a half. And our k is exactly 4. So we know what our a, n, h, and k values are. If we click OK to keep going through this program, as you can see, it's going to ask us for the a, n, h, and k values. So our a1 in this case is 3. Our n is exactly 2. Our h is minus a half. And our k is 4. So we're just going to punch all those values in. And then now you have to do the same thing for function 2. So function 2, I've already nicely put it into this form. So right here, a is minus a half, n is minus 6, and you have to do a bit more work right here because we have x plus 2, but we want x minus something. So this is actually x minus negative 2. So our h is minus 2. Always be careful with signs right there. And our k is equal to minus 7. So we're just going to punch all those values in. So our a is minus a half. Our n is minus 6. Our h is minus 2. And our k is minus 7. And once you've gotten all those values in, Kaz will do some calculations. And what we have right here, if you click the up arrow key and click into the program, we have a base function that we've put in, which is square root of x. And then we have our transformed functions, which is f1 and f2. And you can use this little matrix right here to check if the functions are correct or if they match up to what we have. So f1 right here, that's looking like the exact same thing, and f2, that's basically the same thing. Looks a little bit different, but we just have a half right there which we stuck out the front. So f1 and f2 are the same thing, and if we keep scrolling down, we get the transformation matrices that take us from function 1 to function 2. So this is it right here, and then it also lists the transformations for us. So as you can see, this is quite a powerful thing. All you need to be able to do is describe the transformations on f1 and f2. And if you can describe that, and if you can punch it into the Kaz correctly, then the Kaz can tell you how to get from one function to the other quite easily. So we can actually confirm that this transformation is correct if we just note down the values in the transformation matrices. So the transformation matrices are minus a third, 0, 0, minus a 6, xy plus minus 13 on 6, minus 19 on 3. So that's our transformation matrices. We can use the first functionality of the transform program to confirm that this transformation is in fact the transformation that gets us from f1 to f2. So let's go back to the transform program again. So methods, functions, then we've got our transform. And let's transform this first function. So 3 square root of 2x plus 1 plus 4, comma the variable. And let's transform this function using the transformations that our program gave us previously. So dilation reflection from the y-axis, that's this first number, so minus a third. And then the seconds prompt, we're just going to put in this next value in, so minus 1/6. And then horizontal translation, that's minus 13 on 6. And then vertical translation, minus 19 on 6. Or minus 19 on 3 rather. And if we punch all those in, as you can see, the transformed function, once we apply these transformations, is the exact same thing as what we have for function 2. So indeed, these transformations are correct. So that's another way you can use the transform program. Quite a nice application for that. But yeah, I hope you guys found this video useful, and I'll see everyone in the next video.